Welcome to Configuring ScreenOS Firewalls. This is the session on creating policy-based VPNs. So in the previous session we went over the basic concepts of VPNs and how they negotiate the tunnels between two sites. In this session we're going to talk about creating standard-based policy VPNs. These are the same policy-based VPNs that are out in a plethora of platforms. And in the next session we'll talk about route-based VPNs, which are a Juniper implementation that allows you to split routing from tunneling in order to make VPN operations as flexible as point-to-point on the network. So in this session we already understand all the concepts, so we're just going to dive right in to how we configure and test policy-based VPNs on your network. So at the end of this session, you'll be able to describe the policy-based VPN implementation on the ScreenOS firewalls. You'll be able to identify the components that need to be configured for policy VPN to work in ScreenOS. You will be able to configure policy-based VPNs for phase 1, phase 2, and the custom objects necessary to create those policies themselves. And finally, you'll be able to verify that the operations of the VPN are successful and how to gather troubleshooting information if for some reason the VPN does not come up. So these are the fundamental parts of creating policy-based VPNs that will be covered in this session. It's divided into two parts: configuration and verification. So first we're going to walk through all the parts that need to be configured and then how we can tell that things are working as expected. So policy-based VPN, as we quick review, top level, we are going to match traffic based on address, protocol, and port. And instead of just simply permitting or denying that traffic, we are going to tunnel that traffic through the security of an IPsec VPN to a remote peer. In the ScreenOS, when you create a policy-based VPN, you're doing it in a policy, and your policy action then is going to be tunnel instead of permit or deny. So that's the keyword that's going to tell ScreenOS to apply all the IPsec VPN rules you've configured to this traffic. The proxy ID value is going to come from the address book entries in the policy that you create. So when you have your from and your to addresses on your policy, they will create proxy ID pairs. So the minimum configuration then to have a complete IPsec policy-based VPN between ScreenOS and something else is you're going to have to create on your phase 1 object. You're going to need to know your remote gateway. You're going to need to know what interface you can connect to that remote gateway on. You're going to need an address for that remote gateway, either an IP address or a DNS name. And you're going to need to know what parameters of the proposal you want to have for that connection. So you're going to go through all the options you have in policy proposals, and the remote site and your site are going to agree on what those settings need to be. Some of these proposals are available to you as pre-configured objects that you can select, and if none of the pre-configured objects has exactly the same values you need, then you can create your own proposals. For the phase 2, you're going to create a name for that object, and you're going to need a proposal for this as well. And again, there are pre-configured proposals available, or you can create the exact set of proposals that you want to have between the two peers you're connecting. And then finally, you need to create the actual policy itself that permits the traffic, and then choosing the action of tunnel in order to generate the proxy ID pairs and apply the proposal tunneling options to that traffic and send it down the tunnel. So these are the minimum configurations necessary for the creation of an IPsec VPN on ScreenOS. So how the configuration of this is going to be a 4-step process then. First, you're going to configure the gateway. So there's the gateway object and its advanced options. Then you're going to configure the AutoKey IKE VPN. So you're going to create that VPN and configure its options. Then you're going to need to create address book and services if they don't exist for your policy, and then you create the policy itself. So you need the addresses in order to create the proxy ID pairs, and if there's services that are not existing in the custom service book, or you're not going to use the any object, then you need to create those services, just like any other policy that we went over in the policy lesson. Step 1, creating the gateway. The gateway is set IKE gateway. Named -gateway is the user interface name that you're going to give this. That's free text. Address would be either the DNS name or the IP address, 1.1.1.8. Outgoing -interface, where you are connecting to that gateway through. Pre-share and the shared secret. So this is the pre-shared key that you agree upon with the remote site. So pre-share is the command, and shared secret is whatever that key is. And then sec level and standard. Sec level and standard says we're going to use the parameters in the standard, the proposal called standard. If you go to the proposals section of ScreenOS, you'll see a whole bunch of configured proposals that you can select directly, or you can create your own. In this case, we're just going to use that one called standard. In the web interface, then, we're going to go to VPNs, Auto Key Advanced, and Gateway. And then the main gateway and the advanced screen look like these. You're going to fill in the name you're giving the gateway, the IP address or DNS name, and the pre-shared key for this VPN and the outgoing interface, and then the security level. So these are the minimum configuration necessary for doing the site-to-site VPN gateway. These are your phase 1 parameters. So step 2, we're going to create our IKE VPN, which is essentially our phase 2 parameters. The object is known as VPN, so set VPN named -VPN. We need to associate this phase 2 with a phase 1. So we're going to, in this case, we're going to associate it with the gateway named -gateway that we just created. And we're going to assign a cryptography package for the proposals, and we're also going to use the one called standard. If the standard parameters are not what we want, we can go into the proposal list for phase 2 and again create a custom proposal list that has exactly the parameters we need to negotiate with our remote gateway. On the web, this is under VPN's AutoKey IKE, and we have to fill out the new AutoKey IKE and its advanced properties in the same way. So we give it a name, we associate it with a gateway, and we select the proposal that we're going to use. The next step then will be to create the objects that we need for our policy. This is exactly the same process that we had in the policy lesson, so we're going to go in and create our address objects and any groups necessary, and then we're going to go into services and we'll create any custom services or groups necessary that need to be applied to this policy. No changes in this at all. This is in exactly the same area under policies. Create the objects we need, addresses and services. Now, we do need to determine what policy set is required for our VPN. So here we have a sample network where we have two devices that we're going to tunnel together over the internet. So on the top of this diagram, we have the view of the world from device A, and on the bottom of the diagram we have the view of the world from device B. So at the top you can see the trust zone for device A is Ethernet 3.1 and the LAN, and everything else in this diagram is placed into the untrust zone. So the remote network is untrust to the device A, and the reverse is true for device B. So in device B we have Ethernet 0.1 and 10.30.00/16 is their trust network. So in this case we have a policy we're going to create from untrust to trust, and of course the reverse policy for communication to occur across this tunnel. And these are the address objects that you're going to create for this policy. So you need to look at your local and remote network, assign zones, in this case trust and untrust, and then create your address objects in what you're going to need to have for the policy. So in this case, the policy that we have for device A is going to have a trust address object of 10.10.00/16 and an untrust address object in 10.30.00/16. And then the exact reverse of that will occur on device B. Device B will have a trust address of 10.30.00/16 and an untrust remote address of 10.10.00/16. Now, this is a straightforward trust-untrust two-zone network. You can parse this more finely. You can create custom zones, say remote VPN. You can create a custom zone that says remote office A if you want to put every remote office in its own zone. You can do that. If you want to put all the remote offices in a zone separate from untrust, a VPN zone, you can do that. You can get as narrow or as broad as you want. If you want the remote site to be in the same zone, in trust network zones, you can do that. So this is just an example using a remote is untrust, local is trust example of setting up your policies. So we're going to create the policy, and as I said, this policy is exactly the same as any other policy with only one difference. Instead of an action of permit, we use that bolded command, the action of tunnel, and then we need to identify which VPN object we're going to tunnel it through. So we have tunnel VPN named VPN added to our standard policy command, set policy from trust to untrust, localnet, corpnet, any service, tunnel it over VPN named tunnel, and the reverse policy, untrust to trust so that they can come back, corpnet to localnet, address objects, any service, also tunneled over VPN named VPN. So this is the this is the requirement for the policy, and the policy uses the exact same policy command that we've gone over in the previous session. On the web, you are going to use the same policy creation before. You're going to go into the web interface and select it the same, and you're going to pick down also and use the tunnel instead of permit or deny. So on the web, this is still in policies. You're going to select your trust to untrust or untrust to trust and create a new policy, and you're going to get exactly the same form to fill out. And then in the middle there where it says action, you're going to change action to be tunnel instead of permit, and then you're going to change the tunnel name from none to the particular tunnel that this policy is acting on. So there's two pick lists in the middle there that you need to change: permit to tunnel, and then the tunnel itself to the VPN object that you've created in the previous step. Okay, now that we have a completed VPN created, all four steps are done. We're going to look at the commands you can use to see what's happening with your VPN. You want to generate traffic across the VPN right after it's created. You can send a ping down the tunnel if that's permitted by policy, or generate traffic on the services that you've allowed on that tunnel, or receive traffic from the other side. You want to do something that's going to create traffic that hits your policy. All the policy rules still apply, so you have to make sure your policies are ordered in a way that the traffic you're generating is going to be accepted and acted on by your tunnel policy. So you want to make sure there's no broader policy in front of it that's going to grab that traffic and do something with it before it hits your VPN tunnel policy. So if you want to verify the tunnels, get Ike cookie will show the status of your phase 1 negotiations. It returns back the names of the gateways that are currently accepting traffic, have been up and negotiated, and gives you the current status of that. And to get the status of your phase 2, you're going to use the get SA active one. So in this case, we return back 2 security associations listing there out of the 3 that are listed on the device. So this can tell you which gateway the security association is associated with, IP address and configuration number, the parameters, and the SPI index number in the database. So these tell you at a glance that your phase 1 and phase 2 negotiations have indeed happened. Suppose it hasn't happened and you're not getting anything in the SA database, or the gateways themselves are not coming up. Common errors include proxy ID mismatch, and again, proxy ID pairs are generated based on the address book entries you've put in the policy. So look at the entries, make sure the proxy IDs that you're generating match the remote site. Proposal mismatches, there are a lot of options, the Diffie-Hellman group, the encryption methods, they have to match exactly in order for the communications process to complete. and the pre-shared key, which is necessary for everything to pass through correctly. So if the pre-shared keys don't match, none of these processes will bring through to their conclusion. So these are the three most common things that have to change. If the tunnel won't come up, you're going to have a mismatched proxy ID, a mismatch in the proposals, either phase 1 or phase 2, or the pre-shared key is not going to match. These are the three most common reasons that a VPN does not come up. Finally, routing still counts. So less common, you might assign the wrong outbound interface to the gateway. You might have the wrong IP address on the gateway, or maybe you're using a DNS configuration on the gateway, and DNS isn't resolving on the box. So these routing standard IP stuff, can you ping the gateway? Did you typo the gateway address? So there are some troubleshooting tools available. The event log will show phase 1 and phase 2 errors. Get event is, or looking at the event log on the device will show these errors popping in. For specifically phase 1 problems, that get cookie will show what's going on with the phase 1 negotiation. You can use debug flow basic to try to trap the communications flow by setting your flow filters, and you can use specifically debug IKE command to look at the IKE negotiations on phase 1. In phase 2, get SA active, as we showed earlier, will show whether or not the database has created an entry. You can unset the IKE policy checking so that it won't be as strict in its checking of the details on both sides, and you can use the debug IKE command here as well to take a look at the negotiation commands that are going back and forth between the two gateways. In the system log, where you can see the message, this is probably the easiest way to see what's going wrong in your negotiations. The event type is 536 for VPN related events. So if you get event type 536, you'll see the actual error messages that are being generated by the failed negotiations in phase 1 or phase 2. On the web, these will be in the event log that we've looked at before under report system log. Typical phase 1 errors are going to be unrecognized peer. This will be on the responder side. So if the other side is you have a responder and initiator. Initiator is sending starting the negotiations. Responder is responding to the negotiations. So if the other side is initiating the negotiations and your log says unrecognized peer, that means the IP address or DNS name is not matching what you expect the gateway to be. So this is your IP is misconfigured in your gateway. Proposal mismatch, that means the Diffie-Hellman group or the encryption package or the lifetime or one of these parameters that you've set up in the proposal is different on yours and theirs. So it just says proposal mismatch. You've got to go through step by step in each one of those and see which one you have configured in a different parameter than the remote site. The initiator may see transmission timeout, and this means that they're not getting a response back at all for the request, and the responder will see rejected proposals from peer. So if you get a proposal that does not match anything in your configuration, you will log rejected proposal from peer, but you will not respond to it. So the initiator sees retransmission timeout. It's sending it, it's sending it, it's sending it, and it's not getting a response because the only response you get is an accept. So transmission timeout means the either it's not configured at all on the other site, or the proposal doesn't match what is configured. So if you're trying to bring up a VPN and you see retransmission timeout on your side because you're the initiator, and you're working with someone to bring up a VPN, then that means your proposals are not matching. Common phase 2 errors is the same thing, a proposal mismatch, and again the initiator will see no proposal chosen for phase 2, and the responder will see rejected peer from proposal. So on phase 2 proposal mismatches, and remember you have two sets of parameters for proposals, your phase 1 group and your phase 2 group. So you can successfully complete phase 1 and fail on phase 2. So these are the messages you'll see. If you initiate the traffic, you'll see no proposal chosen. That means they didn't match. And if you're the responder, it's going to be the same message, rejected the proposal from the peer. Also on phase 2, we could have a proxy ID mismatch, and this will be logged as exactly that. My proxy IDs for remote and local network don't match what's seen on the remote site. The responder will say no policy exists for the proxy ID. So in sum, for creating IPsec VPNs, you should be able now to describe what this process is for creating them. You should be able to identify those components that you need to create for the IPsec VPN, the phase 1, the phase 2 proposal, and the policies that go with them. You should be able to configure these bindings, the phase 1 gateway, the phase 2 AutoKey IKE, the address and the service books, and the policy. And you should be able to verify that the policy VPN operations are going through and obtain the event log informations if they're not, or explore the debug commands for seeing what's going on in the exact negotiations. So if you have any questions about the material covered in this chapter, feel free to post them in the public forum on the class website, or take a look at what's been posted there in the past. If you're not comfortable with posting things publicly, by all means contact me privately via the contact information on the class website, and I'll try to respond as soon as I can to any inquiries I receive in that way. Thank you very much for your kind attention on creating policy-based VPNs in the ScreenOS software.